Okay, so starting with number one, I used the simplest case from the language. So I went ahead and set n to 1, and the output of that would be AAB. So I kind of built the PDA on satisfying that AAB. So of course I used the trick of first pushing the dollar sign, and then at the end I would pop the dollar sign. So from my starting variable, which is Q1 to Q2, I would consume an empty string, pop nothing, and then push that dollar sign. And then from Q2 to Q2, I would have two transitions. So one of the transitions would, or I guess each of them would consume an empty string, pop nothing, and then one of them would push an A, and then the other one would push a B. And then from Q2 to Q3, I would just consume an empty string, or consume nothing, pop nothing, and push nothing. So, and then from Q3 to Q3, I would have, again, two transitions. So in this case, following the AAB string, I would want to consume the A and then pop the A from the string, and then consume the A again and then pop the A from the string. From the stack, not from the string. And then I would want to consume the B and then pop the B from the stack. And then from there, I want to empty my stack, so I made sure to pop the dollar sign. So from Q3 to the final state F, I would consume an empty string, pop the dollar sign, and then push nothing. Okay, so for number two, I went ahead and looked at the simplest string, which was AAB, and I went ahead and created the first rule in order for it to satisfy that simple string. So the rule would be AASB, and I went ahead and inserted the S in between the two A's and the B because this would ensure as more A's and B's were added to the string, that the A's would stay together with the A's and the B's would stay together with the B's. So if I had inserted the S in the front or at the end, this wouldn't work because then we would get a mix-up of the two. So it could be AABA or something similar. And then I went ahead and pointed S to epsilon as well because we could see that the language accepts the empty string. Okay, so continuing on the tracing for number two, I first started with the starting variable, which was S, and then I went ahead and substituted S with one of its rules. So in this case, I chose AASB. And then A is a terminal and B is a terminal, so they both stay. So the only one I have to replace now is S, so I went ahead and replaced that with epsilon. And so now I have AA epsilon B, but we don't have to write the epsilon, so now I get AAB, which is what we want. Okay, so for number three, I built the DFA in order to help me build the CFG. So I knew that since the starting state in the DFA is state S, then the first rule in the CFG would be S. So looking back at the DFA, I saw all the transitions from S led into state F. So all the transitions being plus, minus, 0, and 1. So in my CFG, I wrote plus F or minus F or 0F or 1F. So those would be all the rules for the variable S. And then looking back at the DFA, I went ahead and did the same thing for state F. So I saw that there was a transition coming out of F using symbol 0 and 1, and that led back into F. So in my CFG, I wrote F pointing to 0F and F pointing to 1F. And then there was another transition coming out of F that led into the sync state K using plus and minus. So in my CFG, I wrote F pointing to plus K or minus K. And then I wrote F pointing to epsilon because F is an accept state. So there would be a total of 5 rules there. And then for the final state, which was the sync state K, So for the sync states, I know that it kind of like creates like this endless loop. So I know that k can't point to any other variable besides itself. So I did the same thing there, k pointing to plus k or minus k or 0k or 1k. So again, this ensured that k stayed within k. Okay, so the tracing for 3, I started with the starting variable, which is s, and then I went ahead and replaced s with one of its rules. So I chose plus f, and then the plus sign stays because it's a terminal, so I replaced f again with one of its rules, and I chose 0f. So the string here would be plus 0f, and then the plus and the 0 would stay again because they're terminals. And f, I replaced it with 1f, and then the terminals plus 0 and 1 would stay, and f, I replaced it with epsilon, and that would give us plus 0 and 1. Okay, so looking at number 4, the first step is to add a new starting variable and point that new starting variable to the old starting variable. And this is because Chomsky normal form doesn't allow for the starting variable to appear on the right side. So initially that was what was happening. S was pointing to 1s0, so that's not allowed. So an easy fix is just adding a new starting variable. So I was left with s0 pointing to s. Okay, so in the second step, it's to remove all the epsilons that are outside of the like the first rule. So again, Chomsky normal form just wants it in this form. So first I removed the epsilon from, or I guess that's the only one, but I removed the epsilon from s. So s pointing to epsilon is not allowed, so I went ahead and just removed that epsilon. And then wherever I saw an s in the whole CFG, I went ahead and replaced an epsilon with that s. So for example, in the first one, s0 points to s. I created another sort of rule that replaces that s with an epsilon. So s0 was now pointing to s or epsilon. And then in the next rule, s pointing to 1s0, the s there would be replaced with an epsilon. So another rule would be 1 epsilon 0, but I didn't write the epsilon because I'm trying to get rid of the epsilons in the s. So I was just left with 1 and 0. Okay, so now the third step. The third step is taking care of the unit rules. So here, okay, so it's basically just substituting all the single variables with their substitution or definition. And this is because Chomsky normal form wants a variable either pointing to 2 variables or a variable pointing to 1 terminal, and that's it. So I had to replace the s that was that's in the first rule with the definition, with its definition. So 1s0 or 10, and then I left the epsilon because that's fine. Okay, so moving on to step 4, this is basically just putting it in the proper form, and here s0 points to 1s0. Okay, so again, that's not allowed because it's either 2 variables or 1 terminal. So I replaced the 1s with a z, and then I created a new rule that z pointed to vs, and then I created a new rule that b points to 1. And this is again just to follow the proper form for the Chomsky normal form. So continuing on with s0, so now s0 is pointing to zn, and then the next rule, looking at the next rule, is 10. Okay, so 10 isn't allowed, so I replaced the 1 with the rule that I had just written, which V pointing to 1, I replace the 1 with the V. And then I replace the 0 with the n because I had already written that n will equal 0. Or yeah, the substitution for n is 0. Yes, okay. And then the epsilon I just left alone. So, and then S is basically the same thing, so it points to Zn or Zv. And then we're trying to, for the tracing part, I'm trying to consume 1 and 0. So starting with the starting variable, which is S0, I go ahead and replace S0 with one of its substitutions, and here I choose Vn. And then they're both variables, so I have to replace both of them with each of their substitutions. So V I replace with 1, and N I replace with 0. So that leaves me with 1, 0. Okay, so for number 5, the initial CFG is S pointing to 1S0 or the empty string. So reading the rules, it first says to push the $ first onto the stack. So I went ahead and created a transition from my starting state, which I named Q1, to Q2. I went ahead and popped nothing and pushed that $. And this is because we're using that rule of pushing the $ in the very beginning and then popping it at the very end before reaching that final state. And then after, the rules state to go ahead and push the starting variable onto the stack next. So from Q2 to Q loop, I consumed an empty string, popped nothing, and then pushed that S. And then next, the rules sort of state to sort of replace the variable S with each of its rules. So first I focused on 1S0. So from Q loop to Q3, I went ahead and popped that S, again because we're replacing it, and I pushed the 0 first. And then I popped nothing from Q3 to Q4. There was a transition that popped nothing and pushed the S. And then from Q4 to Q loop, it consumed an empty string, popped nothing, and then pushed that 1. And I did it backwards because this ensures that when each of these symbols are popped, that they're gonna be read in that the correct order, because the stack is first in, last out. So I did this for the rule. So S points to epsilon, so I did that for that rule too. So I would pop the S and then push the epsilon, and there was no new state that needed to be added because it's just one sort of variable. So the source would be Q loop and the destination would be Q loop. And then next, the rules state that if the input string reads a terminal, so in this case either 1 or 0, that terminal would be read, would be consumed, and then it would be popped from the stack. So it would have to be at the very top of the stack. So I created a transition from Q loop to Q loop. So one of the transitions would be to consume the 1 and then pop the 1 and then push nothing. And then the other transition would consume the 0, pop the 0, and then consume nothing. And then finally at the very end, again using that trick of popping the $ at the very end, and so I created a transition from Q loop to Q final, popping that $ and pushing nothing. And this would ensure that the stack would be empty and that we could actually accept the input string. For number 6, transforming the PDA to a CFG, the first step is to ensure that the PDA is already in its proper form, which in this case it wasn't because of the fact that there's 2 accept states and there should only be 1, and then also because it doesn't use that trick of pushing the $ at the beginning and then popping it at the very end. So what I did to fix this is I created a start state and a new start state, and then I connected that new start state to the old start state. And the transition, I used that it would consume epsilon, or consume empty string, push the $, and then pop nothing. And then I created a new accept state and connected the old accept states, so S1 and S0, connected those to this new accept state. And then the transition from S1 to A would read that it would consume an epsilon, pop the $, and then push nothing. And then there would be also another transition from S1 to A that would that would consume an epsilon, pop nothing, and then push nothing. And this is only because I created that new accept state, and that's how the old ones are connected to the new one. And then the same thing, the same transition for S0 going to A. So continuing with number 6, I went ahead and created the start variable for the CFG, which was AFA, and I knew this because F is the starting state and A is the accept state. So for now, I would just leave that be, and then later I would fill out the actual the substitutions for that one, for that variable. So moving on to the next rule for now, I went ahead and looked at the PDA, and then I searched for a transition that would push a symbol other than the empty string. So in this case, there was 2, but I focused on the first one, which was a transition coming out of S1 going back into S1. So this transition read that 1 would be consumed, epsilon would be popped, or nothing would be popped, and then 1 would be pushed. So I went ahead and assigned the variables for that one. So P being the source state, A being what was consumed, and then T being the push symbol, and then R being the destination symbol. So yeah, so I went ahead and assigned those variables. And then next I would look for a transition that this time popped the same variable, the same symbol as before, so the same symbol being a 1. So there was actually 2. And well, first I would focus on the transition from S1 to S0, and this transition read that it would consume a 0, pop a 1, and then push nothing. And then I would assign the variables S, Q, and B. So S would be the source state, which was S1, Q would be the destination state, which was S0, and then B would be the symbol that was being consumed by the transition, which was 0. So using all those all those variables, I would go ahead and create the next rule in the CFG. So using the formula APQ pointing to lowercase a, uppercase A, RSB, I would go ahead and replace all those variables with what I had just filled out using the transitions. So the rule would read A S1 S0 pointing to 1 A S1 S1 0. So that would be my first, or I guess my second rule. And then the third rule would be to find another transition that would also pop a 1 from the PDA. So looking at the PDA, I could see here that there was another one that would pop a 1, and that was from S0 to back into S0. So this transition read that 0 was being consumed, 1 was being popped, and epsilon was being pushed. So I did the same thing again, where I assigned S, Q, and B, and then I went ahead and made the third rule. So using the same formula as before, the rule came out to be A S1 S0 pointing to 1 uppercase A S1 S0 and then 0. And then since I was done with all the transitions that popped a 1, I went ahead and looked for a different transition that pushed a symbol apart from the empty string. So in this case, there was one other one, and that was the one at the beginning that that actually pushes the $sign. So okay, so now focusing on that transition, I assigned the variables P, T, A, and R, and then I looked for another transition that now popped the $sign. So again, there were 2 other transitions, one going from S1 to A and then S0 to A. So again, I went ahead and filled out the variables S, Q, and B for each of those 2 transitions, and then again created the rules using the formulas. And then from there, I kind of just combined what I could. So AFA, I kept that as a starting variable, and that would point to AS1S1 or AS1S0. So I kind of grouped them together. And then my second rule would be AS1S0, pointing to A, uppercase A, S1, S10, or 1A, S1, S0, 0. So number 7, so I just followed the algorithm for this one, and it says that basically if the first scan character is a opening parentheses, that you can just go ahead and push that onto the stack. So that's what I did. And then it says if the next scan character is an operand, which it is because it's an 11, just go ahead and output it. And then from there, the next scan character would be a +sign. And it says that if whatever's in the stack is a parentheses, then you could just go ahead and push that +sign onto the stack as well. And then my next scan character is a 1. So so I went ahead and output that one as well. And then the next scan character is a parentheses. So the algorithm here says that if it's a closing parentheses, that you could pop everything until you reach the opening parentheses. So in this case, I popped the +sign and then I popped the parentheses. So that parentheses, well, the 2 parentheses, I just discarded them because, well, yeah, you don't need to output them. And then I outputted that +sign. So next came that division sign, and it says, so if the stack is empty, you could just push this division sign onto the stack. So that's what I did. And then the next scan character is an opening parentheses. So I went ahead and again pushed that opening parentheses onto the stack. And then the next scan character is a 20, so I went ahead and output that one. And then the next scan character is a -sign. So I also went ahead and pushed that one onto the stack. And then 17, I went ahead and outputted it because again, it's an operand. And then I reached the last character, which was the closing parentheses. So again, for this one, I just pushed, or I'm sorry, I popped everything from the stack until I reached the opening parentheses. So in this case, I popped the -sign and then the parentheses. But again, the parentheses, I could just discard it. And then, so yeah, I outputted the -sign. And then since I reached the end of the equation, the algorithm says that you could just pop everything that's in the stack. So that's when I popped the division sign. Okay, so continuing 7, I left off with the postfix was 11, 1, the +sign, 20, 17, the -sign, and then the division sign. So now I actually want to produce the answer, and again I use the algorithm for this one. And so looking at the postfix, the first scan character is an 11, So I can just go ahead and push that one onto the stack. And then the next scan character is a 1, so again, push that one onto the stack. And then the next scan character is an operator. So whenever there's an operator, you could just pop twice from the stack. So I went ahead and popped the 1 and the 11, and then I performed the addition. So 1 plus 11, 12. So I went ahead and pushed 12 onto the stack. And then following the postfix, the next scan character is a 20. Yeah, and so I went ahead and pushed the 20 onto the stack, and then the next scan character is a 17, so I went ahead and pushed that 17 onto the stack, and then the next scan character is a minus sign. So that minus sign, I can go ahead and pop the last two symbols from the stack, and then go ahead and perform the subtraction. So 20 minus 17 is 3, so I went ahead and pushed the 3 onto the stack. And then continuing with the postfix, I left off at the division sign. So again, an operator, I can pop the last two characters, so 3 and a 12. So 12 divided by 3 is 4, and 4, I go ahead and push it onto the stack, and that's my answer. So the last one, number 8, the string that I used was A to the P, and then B to the P plus 1, and then C to the P plus 2. So I chose this because from the language it says that there has to be more B's than A's and then more C's than B's. So then I went ahead and created the 5 cases. So the first one says that if U is the empty string, then X, Y, and Z contains only A's because the length of A's already equals P, and X, Y, and Z in this case can equal P or less than P. So it can only equal those A's. And then case 2, if the length of U equals P, so basically if the length of U contains the A's, therefore the XYZ contains only the B's. Then the length of U is 2 times the length of P, therefore XYZ can contain the B's and the C's since the U already contains all of the A's. And then the length of U is in between 0 and P, and therefore XYZ contains A's and B's. So in this case, since U is less than P, that means there's still A's that need to be like covered. So that's why XYZ can contain A's and then some B's. And then the last one, P is the length of U is in between P and 2P, and this is okay. So now taking the string that I chose, this string shows that the length of B is only going to be 1 more than the length of the A, and then the length of the C is going to be only 1 more than the length of the B. So the difference for each is, or the difference for A and B is only 1, B and C is only 1. So when I applied this first condition, that difference of 1 between them wouldn't hold. So that's why, and this is the case for all of them. So when this condition is applied to all of them, the difference of 1 is not going to hold. So that's why this is not a part of the language.